Here we are here to solve a JEE Advanced 2020 question. The question is the first and the second and third ionization enthalpies of I1, I2, I3 of four atoms with atomic number n plus 1, n plus 2, and n plus 3, where n is less than 10 or tabled below. Then what is the value of n? That is the question. So if we look at this question here, we can find that they are given the atomic number, ionization enthalpy in kilojoule per mole. So carefully observe this table. Here you can see that you can clearly observe that the difference between this and this is gonna be very maximum, which means that this element has is a metal, and it is ready to lose its electron, which means that it must have a valency 1. When it loses an electron, it outermost that shell has valency 0, which means it has finally obtained an octet 8 here. So what are the probabilities of having 1 in the outer shell? Either it should be 11 or 3. These are the probabilities here. So either it would be either it would be 1, 2, 3, 4, or 11 should be here. So 11 minus 1 10, 10 minus 1 9, 11 plus 1 12. So these are the probabilities here. But here you can note that the ionization energy of this, it has three ionization energy. If it has only one electron in its outermost shell, then how come it would be have three ionization energy? So the answer should be 9, 10, 11, 12. So how can we check whether the answer is 9, 10, 11, 12? So here you can see that, let's check whether it would be 9 here. So if it has 9 electrons in first ion, it requires some energy, that is 161. So it would also get an octet. To not get out octet here, 26 2,6 would be the electronic configuration, and it would take some amount of energy here. Then 2,5 would be there. As you can see here, for 9, 1 is 2, 2 is 2, 2p, 2p5, yeah, 2p5. So if it is going to lose electron here, 1 s 2, 2 s 2, 2 s 2, 2p4 it will become here. So here it will become 4, which records a little bit of energy here. So if it is going to become 2p3, 2p3 would have 3 electron in its valence cell, isn't it? Yeah. 1s2, 2s2, 2p3 it would be have. After 2p3 you can see the large amount of difference. See here, 6550. So as per the electronic configuration here, 1, 2, 3. So one electron, sorry, clear page. Yeah. Here you can see here, 1, 1. So the electron in p orbital would be filled like this: 1, 1, 1, 1, 1, 1. So if it is going to be lose one electron for you, then this electron would have been vanished. This electron would have vanished easily. Then this electron would have vanished easily. But if it would be easily for the electron to gain 3, sorry 4, from 4 to gain 3. But for half filled and fully filled orbits, it is does not allow the electron to escape. So here the electron does not escape and it provides a lot amount of energy. So the answer is going to be 9.00. Why 9.00? As in J advanced, you should keep two decimals. If you give an answer as 9, it would take wrong. So two decimals. So 9.00 is the answer. The question was very simple. If you can, if you can easily solve this question is gonna to be very easy to you. And this question often is asked in examination. Here, if you want to see the second value present here, 9 plus 1, 2081, 3952, 6122. So as you see here, 9 plus 1, it will be 10 electron in its outermost, isn't it? Yeah, 9. 9 plus 1, 10 electron. 10 electron means what? 1s2, 2s2, 2p6. Am I right? Yeah. It would lose its first electron here, 1s2, 2s2, 2p, 2p5, and it would lose its second electron here, 1s2, 2s2, 2p4 easily. But as it is becoming here more electropositive, as it is becoming 1s2, 2s2, 2p4, this shows a little bit graduation here, 6122, as the electron now is near to the nucleus and requires a lot amount of energy to break that bond here. So for NP3, it would be 12 here, and it would easily lose it 2 electrons, becoming 10, becoming a noble gas configuration. It would nevertheless give an electron, resulting in a higher value. Same is the case for this, same is the case for this, same is the case for this too. So if you want to conclude here, the value should be 9, 10, 11, 12, depending upon our accuracy. We guessed it as n plus 1 means, see here, 2081, 3952, 6122, lot amount of jump here. See here, the virtually there is no difference between this and this, but if you see here there's more difference in it. It indicates that this has either to be one electron losing, or see, one electron losing system should be, so 11 or 3. If 11, we can go with this. 3 is not possible as one electron cannot have 3 ionization energy. So 9, 10, 11, 12. You can also verify by this too, I think. Yeah, absolutely you can verify, man. So noble gases would have configuration of here 9 plus 1, 10, 1s2, 2s2, 2p6. When first electron is removed under high pressure, 1s2, 2s2, 2p5, the next electron can also be removed easily. 1s2, 2s2, 2p4. But in noble gases, the atoms are very inert and they does not allow the next electron to escape as it is. So 1s2, 2 is 2p3. If it becomes 2p3 here, see, can you now figure out why this value is changing here? 1, 2, 3. But why this value has a higher amount of energy here? As it's just becoming 2p3, it can just lose an electron. But noble gases generally does not allow the electron to escape from that. Imagine 10 electrons are there. Imagine 10 electrons are there, and already you have removed 2 electrons, so you will have 8. So I said 10 protons, I think so. Protons. Wait, let me. 10 protons are there, and you have removed 2 electrons, so 8 electrons. 10 protons attaching to 8 electrons is somewhat difficult to remove, and noble gas doesn't want to react them. Other gases would allow them, as my p orbital does not want. I don't want my p orbital to become 4 electrons. I can just let you, but noble gases want an octet configuration, and does not allow the electron to escape here, which results in that value here. So the answer is gonna to be 9.00. Can you now understand how simple the question was? It was asked in JEE Mains 2020, the most luckiest badge ever. Okay, thank you. I hope so. The question was easy and you could understand.